All right, we're going to look at complex zeros today and how you factor a polynomial and find both the real and complex zeros of it. Okay, so when you're doing these problems, what you're going to look to do first is to do any kind of factoring. And we always look for greatest common factor first. So if there's a greatest common factor, you want to try to find it. So if we look at this first polynomial here, what can be factored out of there? Well, greatest common factor is where we're looking first. I see that there's a greatest common factor there of x squared. We can divide both of those by an x squared. So we're going to do that first. Let's factor out an x squared. And then we want to see what's left over when we do that. So if we divided x to the fourth by x squared, we'd have another x squared left over. If we took 3x squared and divided by x squared, all that would be left is the 3. So that's the first step. Second step now, we want to see, can it be factored any further? So does this stuff in the parentheses still factor more? It doesn't look like it. That's not a difference of squares or anything that we've really looked at before. So what we're going to do next then is take that and we're going to solve it for 0. Okay, we're going to solve both of them for 0. So what do we get if we solve both of these for 0? The first one's pretty simple. If we put x squared equal to 0 and we solve that square root, we know we're going to get 0. So one of the answers, or one of the zeros to this one, is x equals 0. Okay, but then this other factor has some more zeros we want to find. So let's solve this one now. Let's subtract 3. And let's square root again. Now in this one, we're going to end up, when we take the square root here, is that we're going to end up with plus or minus the square root of -3. Now we know from working with some of these imaginary numbers that this is not a real 0. That negative under the square root is going to come out and turn into an I. So we got two imaginary roots to this one as well. So our two imaginary roots are this complex number, or imaginary number of square root of 3, and also negative. Oh, forgot the negative 1 as well. So those are our 3 zeros. So when we write this one out now, in factored form always shows it's not the 0, but the factored form of that. So just in an example, let's say in your problem, x equals 5 is a 0. That means a factor of this is x minus that number. So x minus 5 is a factor when x equals 5 is a 0. So when we're writing this out now, this polynomial in its completely factored form, we got this factor of x squared, and then this x squared plus 3 would factor out into the 2 zeros that we got from it, subtracted from x. So we would end up with x minus positive I square root of 3 and x minus negative I square root of 3. And those would be that would be the complete factored form of that. That answer would be perfectly fine to go with. If you were looking at this one as a way to maybe simplify this a little bit here, we know that this parentheses really isn't doing anything, so we could remove that if we wanted. Also in this next one, we got subtracting a negative. So if you wanted to write it in a little bit better form here, minus a negative would be the same as plus. So if you want to go a little bit further, that's a nicer way to write that answer. All right, let's try another one of these. Completely factor this one, and then write out its zeros as well. So first, I always look greatest common factor again. This one I see that all of them have at least one x in there. So let's take out that greatest common factor of x. And then this would be what we have left over. So now to finish this one, you want to look at, again, what's in this parentheses? Can it be factored anymore? Well, first thing you'd want to check, could we possibly factor that into two binomials where we got x and x? Is there something that multiplies to 1 and adds to -3? Nope. So then if you can't factor it out easily like that, our other way we know we can always solve quadratics is to use quadratic formula. So if we're doing this with quadratic formula, our a is 1, our b is -3, our c is 1. So let's put that into quadratic here. See the zeros that we get from that. So we got opposite of -3 plus or minus the square root, -3 squared minus 4 times 1 all over 2 times 1. That's going to simplify to +3 out here. We got 2 on bottom. And in that parentheses, we got 9 minus 4 times 1 times 1 is 4. So 9 minus 4 is 5. So square root of 5. So the zeros then that we get from this one are that here, since we just got a plain old x, we know one of these factors is 0 then, because if we put that equal to 0, it would be 0. The other two solutions we get are those ones we just got over there. We get 3 plus square root of 5, and then both of those numbers get divided by 2. So we get that factor. Oop, that's 3 there. And then our other factor, we got 3 minus square root of 5, both divided by 2. So those would be our our 3 factors on this one. All right, so, or not 3 factors, our 3 zeros. What is our factors then? We should have a factor then for all these. So we got this factor of x, and then we got x minus our zeros. So we got x minus this factor of 3/2 plus square root of 5 over 2. And then we got this other one of x minus 3/2 minus square root of 5 over 2. And those would be our factors. So the factored form of this one would be right here. All right, number 3. This one, we're, again, factored completely here. This one, to factor this one, you can notice that this one is one of those difference of squares. Both this term and this term, we could take the square root and find a perfect square there. So this, and it's subtracting. So this one is a difference of squares. What are the two things that we have being squared here? So if we took square root of this, what would we get? X squared and x squared. So those would be the two things multiplying to get the x to the 4th. What's the two things that multiply that are the same to get 81? 9 and 9, because that's a square root of 81 is 9. And then because this is a subtraction sign here, one of these has to be positive and one of them has to be negative. So that's completely factoring that. Now, we want to solve both of these or see if we can factor it more. One of these factors more. This one still factors more. We can do another difference of squares there. So this one can't be factored, the first one, because it's a plus, but if it's a minus, it can be. That would factor to x minus 3 and x plus 3 in a very similar manner to the way we factored originally. Now this last one, though, we still have to solve this one. So let's see what that one factors or solves to. If we put it equal to 0 and solve it, what do we get? Well, we can minus 9, take the square root, so we got plus or minus the square root of -9, which is going to give us plus or minus, change that to imaginary number, I squared of 9, and then we get plus or minus 3i, because square root of 9 is 3. So our zeros here, and we got to remember we have these two factors here as well. So those two factors would give us, if we put them equal to 0, 3 and negative 3. And then the two zeros we just got solving over there. So we get positive 3i and negative 3i. So this one has 4 factors to it. So now when we write this out in the very final factored form here, we want to have a factor for each of those zeros. So we got our x minus 3, we got our x plus 3 that we just had, and then what do we get? What are the two factors that come from this one? X minus 3i and x plus 3i, because it'd be like minus and negative. So that would be the final factored form of that one. Okay, we also had these difference of square ones difference of cubes and sum of cubed ones as well that we want to look at here. So what do we get from these ones? Well, when you have a difference of cube or sum of cubes, you want to figure out what is being cubed in each of these two spots, figure out those a and b numbers, and then it comes out to be this factored form shown to the right there. So on this one, what are the two things being cubed? Well, x is being cubed, and then for 27, it would be that 3 is being cubed, because if you do the cubed of 27, you get 3, and the reason is 3 to the third power equals 27. All right, so once you know those two things, then you're going to place those numbers in place of a and b. So here, wherever we have an a, we're going to put x. Wherever we have a b, we're going to put 3, and then that should end up being the factored form of this one. All right, so the factored form of this will end up being, it looks like we got x plus 3 times x squared, which is just x squared, minus x times 3, which is 3x, and then plus 3 squared. Well, 3 squared is 9. So that's the factored form of that. Now that first one, this one, that can't be factored anymore. That's x to the first power. The second one should be either able to be factored or at least solved further, because you can see there's still a power bigger than 1 on there. I don't think there's any numbers that multiply to positive 9 and add to negative 3. So that's telling me we got to go quadratic on this one. So we got an a of 1, a b of negative 3, a c of 9. What do we get from that? So we got opposite of negative 3 plus or minus the square root, negative 3 squared, minus 4 times 1 times 9, all over 2 times 1. That's going to give us positive 3 there, 2 on bottom. Our square root there, we got 9 is what we get when we take negative 3 times negative 3, and then 4 times 1 times 9 is going to be 36. So we got 9 minus 36, which is going to end up being negative 27. Okay. Clearly, we can't do square root of negative 27 and get a real number. So it looks like the answers to these ones are going to be complex numbers here. We can simplify that. Let's continue simplifying. We can take out that negative and make it I. And also, square root of 27 does have a perfect square in there, perfect square of 9. 9 times 3 is 27, so we could write that as 3 square roots of 3. All over 2. So that's going to be our zeros here. So our zeros from this one, we got a real one of negative 3. Because if we put that equal to 0 and solve it, we get negative 3. Our other two one are these two complex ones over here. So we're going to get 3 plus I 3 square roots of 3, both of them over 2 here. And then our other one we're going to get is same thing, but subtracting. Okay, So now to write that out in factored form, we want to write all three of those. So we get this x plus 3. We also have the x minus this one. And then we have x minus the second one. And these would be the 3 factors of this one. So that's the factored form, and these would be the 3 zeros that we get. Okay, one last type of factoring you want to look at is this one. Again, always look greatest common factor first. It looks like maybe you could take an x out until you get to that last one. There's not an x to be factored out there. I see a couple of these with 3's, but the other ones don't have 3. So there is no greatest common factor we can take out on this one. It's also not a difference of difference of cubes or difference of squares. One last way you can check is grouping. What if we were to group these 2 factors and these 2 factors? Is there a greatest common factor we could take out here? There is. And that first one, we could factor out, if we just group those 2, we could factor out an x squared. What would be left over then is x minus 3. On the second one, nothing can be factored out except a 1. That's the only thing in common with both of those. But if you notice now, both of these still have a same term. So we could factor that x minus 3 out. And what's left over then is x squared plus 1. And that is the factored form of that using grouping. Now, one of these, this first one, we know the 0 from that. If we put that equal to 0 and solve, we get 3. So that's one of the zeros. What's the 0 that comes from this second one? So that's the one. That one is not one we can factor. So let's just put it equal to 0 and solve it. See what we get. Minus 1. Square root, so we get plus or minus. Square root of negative 1. We know that turns into I if we pull out the negative. And square root of 1 is 1. So if you want to write the 1 there, you can, or you can just write it as plus or minus I. And so the 2 other zeros on this one are I and negative I. So our factors on this one end up being x minus 3, x minus I, and x plus I. That would be the factored form of these 3 zeros. You might have some combinations of these. So let's look at this one. Factor this one completely. I don't see any greatest common factors. It's also, there's no grouping one we can do on this one. But it might be factored similar to like how a quadratic gets factored. So let's look here. What if we split this into 2 binomials? Well, if I see an x to the 4th here, that tells me both of these would have to be x squared. Now we're thinking, what's going to multiply to negative 8, but also add to negative 2? Well, we could get that accomplished with minus 4 and plus 2. That multiplies negative 8 and adds to negative 2. Now, like you always want to do, if it's bigger than a power of 1, which both of these are, can they be factored anymore? That first one looks like it can be. That's a difference of squares. The second one, no, because it's adding and there's no factoring. But this one's a difference of squares that factors to x plus 2 and x minus 2. So now our last thing is we know the zeros that come from these first 2. They would be x equals 2 and x equals negative 2 if we put them equal to 0 and solve. What are the zeros that come from the second one? So put it equal to 0 and solve. Take the square root, so we got plus or minus the square root of negative 2. We know with that negative there, these are going to be imaginary, so pull out the I. And square root of 2 doesn't simplify, so our 2 other zeros here are I square root of 2 and negative I square root of 2. So those are our 4 zeros. Now we want to write it in factored form with 4 factors. So the first two we can just leave. This last one, though, the factors that would come from that would be x minus I square root of 2. And then the second one would be x minus negative I square root of 2. Easier way to write that, or nicer way to write that, instead of minus and negative, you can write a plus. And so that would be the factored form, complete factored form of that polynomial. All right, there's one more here. Let's have you guys pause the video, try this one out on your own, and then we'll kind of check and see how it went for you. All right, hopefully you had some time to try this one. This one we want to factor like a quadratic here. We got x to the 4, so you got x squared and x squared here. What's going to multiply to 2 and add to 3? That would be 2 times 1. And so our two factors there are x squared plus 2 and x squared plus 1. Neither factor, so you want to come over here now and look to solve these. And if you did it right, you should have got plus or minus I squared of 2 for the first one and plus or minus I for the other one, giving you these zeros. Now the last thing we want to do is just write that out in the final factored form. So this first one we'd write as x minus I squared of 2, and then x minus a negative, or x plus I squared of 2. And then we got x minus I and x minus negative I, which turns to x plus I. So that would be the final factored form. Hopefully you got there and got that. So that's what you're going to try out now on your practice.